Hey there, and welcome to this explainer. Grab your hard hat, because today you and I are stepping right into the boots of a lead safety inspector. We're heading out onto a busy plant floor for a full audit, and let me tell you, we aren't just here to hand out a few pairs of safety glasses and check some boxes. No way. We're looking at the big picture, the machinery, the processes, and we're going to figure out how to engineer risk completely out of existence. It's a high-stakes walkthrough, so let's see exactly how it's done.
Okay, let's dive into this. Here's our clipboard agenda for the walkthrough. First, the safety inspector audit. Second, engineering out the source. Third, enclosures and smart barriers. Fourth, deciphering danger and caution. And finally, number 5, your plant compliance checklist.
Section 1, the safety inspector audit.
So before we inspect a single piece of machinery, we've really got to understand the fundamental equation of workplace risk, which is simply this: a hazard plus an exposure equals an accident. If a worker's hand meets a spinning blade, boom, that's an accident. The crucial point here is how we choose to break that equation. It's the difference between engineering controls and administrative controls, or PPE. Administrative strategies basically just manage the exposed worker, right? It's giving them earplugs to survive a deafening room. But engineering controls, they actually fix the source. We literally engineer the machine to be quiet in the first place. It's fascinating because eliminating danger at its origin heavily outranks just handing someone protective gear.
To really ground this in reality, let's look at these workers facing some serious real-world exposures. We've got manual sanding kicking up massive dust clouds and active welding throwing off toxic fumes. Now sure, slapping a mask on them is the quick administrative fix, but as safety inspectors, our challenge is different. How do we intervene at this source? How do we totally re-engineer the environment so the air is perfectly clean before it even gets anywhere near their lungs?
Section 2, engineering out the source. Well, if we want to stop relying on masks and temporary band-aids, we have to redesign the facility so the hazard simply doesn't exist anymore. The absolute most elegant engineering control is simple substitution. It's a really clean 3-step process. First, you identify the threat. Say, a highly volatile chemical solvent. Step 2, you source a non-toxic alternative. And step 3, you replace it. Swap that lethal chemical for a safe, water-based cleaner, and the hazard is literally wiped off the board. No special masks required. Let's move to and see how this builds, because this concept also applies beautifully to the physical layout of the floor when we're talking about ergonomic safety. First, we audit the physical workflow to see exactly how a worker is moving. Next, we pinpoint those awkward, repetitive movements that are causing strain. Finally, we completely redesign the workstation. Honestly, just by repositioning a conveyor belt or tweaking a table's height, we can engineer away the source of chronic physical injury. It's a total game changer.
Section 3, enclosures and smart barriers.
All right, as we continue our walkthrough, we're going to hit a zone where processes cannot simply be substituted or redesigned away. I mean, we can't exactly substitute the massive heat of a foundry or the crushing gears of a press, right? So we turn to complete containment. It's a highly dramatic intervention. You're taking moving parts, toxic liquids, or deafening noise and locking the whole shebang inside a completely sealed box. It's amazing to witness out on the floor. A machine can be absolutely roaring and spewing toxic gas inside this enclosure, while a worker standing literally 2 feet away is peacefully drinking their morning coffee, breathing perfectly clean air.
But when a complete enclosure just isn't feasible, we establish barriers. And you have to notice the evolution here. It's wild. The old-school traditional methods rely on things like physical noise baffles or fixed metal guards to physically block a worker's hand. But modern tech is incredible. We can now deploy electronic smart barriers that sense human proximity and instantly kill the machine's power. Or we use automated local ventilation hoods that aggressively suck hazards right out of the worker's breathing zone. Now, of course, for maintenance, those barriers have to come down. And this brilliantly illustrates where positive lockout devices come in. Look at this physical valve lockout. During service, these machines can release incredibly hazardous electrical or pneumatic energy. A sturdy padlock keeps the valve continuously in the off position, quite literally blocking the flow of energy. It renders the equipment completely inoperable until that specific lock is removed. It is the ultimate physical veto against an accidental startup.
Section 4, deciphering danger and caution.
Okay, let's shift our audit focus to the visual environment, the signs plastered on the walls and machinery. Safety signs are actually a strictly regulated visual language. According to ANSI standards, the absolute highest warning level is danger. This explicitly indicates an immediately hazardous situation which, if not avoided, will result in death or serious injury. These signs are legally and strictly limited to only the most extreme, life-threatening situations on the factory floor.
So, what does this all mean for us? Well, the distinction between danger and caution is absolutely vital. Caution is strictly for potential hazards that might result in minor or moderate injuries, or just unsafe practices. If a facility management team plasters danger signs on every minor trip hazard or spilled puddle of water, workers quickly develop what we call sign blindness. When they finally face a truly lethal threat, they might just walk right past the warning and ignore it entirely. That strict separation is just as important for human psychology as it is for OSHA compliance.
Here's a perfect real-world example, a classic danger tag. That stark red, black, and white design is completely unmistakable. If a piece of equipment is so damaged that merely turning it on presents a major threat of severe injury, this tag goes right on it. It communicates to everyone instantly, loud and clear. Do not touch this, your life is immediately at risk. Now, what's really interesting about this slide is how the visual language shifts for lesser threats. These bright orange and yellow warning and caution tags represent non-immediate or potential hazards. They might flag some flammable materials nearby or warn that removing the tag is going to result in disciplinary action. They are absolutely crucial for safe daily operations, but they explicitly do not carry the immediate life-or-death weight of that red danger tag.
Section 5. Your plant compliance checklist.
All right, flip to the last page of your clipboard. Let's rapid fire through this compliance checklist to make sure we've distilled everything we covered today. 1. Always target engineering controls at the hazard source first, way before you resort to PPE. 2. Actively substitute toxic materials wherever possible. 3. Execute step-by-step ergonomic redesigns. 4. Deploy complete enclosures and electronic smart barriers when those hazards just can't be removed. And 5. Strictly separate your ANSI danger versus caution signage to preserve their psychological impact.
Before we wrap up this explainer, I want to leave you with this provocative thought as you head back to your own factory floors. Look really closely at your current safety measures and ask yourself, are your controls actually fixing the hazard right at its source? Are you just putting a temporary Band-Aid on the worker and hoping for the best? True safety engineering eliminates the danger entirely. Thanks so much for joining me on this explainer, and stay safe out there.